Okay, so the air pollution comes in many shape and forms, and mostly is coming as from the from out, as you will see it later on, from electrical power plants, and they come from the some extent to nuclear plants, and for the manufacturing chemical companies. So those can put a lot of air pollutants, as well as fresh tap water pollutants. So, but as I said, you will see here the same problem you had before. You have two types. You have an open buoyant, and you have non-open buoyant. Open buoyant means you know the source of this pollution. You know who had caused what. That's because they are registered factories and industries. They are registered. You know what they are producing and what they are dumping inside the air, correct? And the other side, which is very hard to track, those are non-buoyant type of sources, which really is very hard. Very hard. If you have some people, they have a little bit of in their field or in the backyard, whatever they are cooking, whatever they are making stuff, and then they let whatever they vented to the air. So the non-open sources, that's always hard to track. But the ones it's open, that's the majority pollution will come from. That's what we're expecting. But that's still there are some regulations and rules ruling them. So pollutants, air pollutants may irritate our eyes and lungs, enter our bloodstream when we breathe them, and damage nerves and brain function. Okay, guys, and if you have those are living near the electrical power plants, they can feel it sometimes. Whatever is happening, sometimes by mistake or there is an accident, you will see something coming to your eyes. Especially if there's a rainy day, you'll see your skin is start irritating, and your eyes burning. And this happened to me one time. Was in my house in Snellville. So it's a lot of. I think there was something done by mistake or an accident, but there's a lot of acid rain came through. So I had to take shelter, get out of the backyard. So yeah, that's those type of stuff. The acid rain, you will see what's the source of acid rain. Source of acid rain is sulfur becoming sulfur oxide, sulfur dioxide, and then goes in the air, interact with the moisture, gets sulfuric acid. Nitrogen deoxidized to nitrogen oxide, goes to the air, interact with moisture, H2O, comes as nitric acid. So the major rain acids are sulfuric acid and nitric acid, which can do damage for the humans as well as soil as well as plants. So they can do a lot of damage for the environment, including the humans. Clean Air Act regulates major pollutants. In 1970, the Clean Air Act passed new air quality standards and was applied equally across the country for 6 major pollutants. And we will go through those pollutants together. You will see those coming there. So those 6 pollutants are given the specific classification as conventional pollutants, correct? Conventional pollutants, and those are because they are in most industries, in most human activities. You will see them there. One of them sulfur, which then turned out to sulfur dioxide, nitrogen oxide, carbon monoxide, ozone. Those are how many? 1, 2, 3, 4, and some organic volatiles, and lead. So those are the 6 ones. Those are the 6 ones called conventional pollutants, and they can cause a lot of damage in the air, as well as for the damage for the soil and the plants. Transportation and power plants are dominant sources of most of those pollutants. That's what I said. Anytime you live near electrical power plants, you can expect a lot of, sometimes by just an accident happened, and then something vented to the air, and whenever the whatever vented in the air will stay in the air because of the density differences. Then as soon as you have the rain will wash everything down to the ground. So that's what we see, and that's what we feel, all this acidic burn in our eyes and skins. Unconventional pollutants. We have conventional, we know those, carbon dioxide, carbon monoxide, sulfur dioxide, lead, the chlorofluorinated compound. All those are conventional. And unconventional one, those are produced in less amount, less volume than conventional, and they are the same things, toxic as well. Among those, among those unconventional pollutants, asbestos, benzene, beryllium, mercury, polychlorinated biphenyls, and phenyl chlorides. And if you can see all those here, besides what we have before, the conventional ones, pollutants, might not cause cancer, for example. But those here, you can see them here, most of this unconventional can cause cancer. Those here, this was highlighted, those here, they can cause easily cancer. Compared with the other ones. The other ones can do damage, but not really cancer related. Like lead, that's heavy metals. Heavy metals can destroy the liver and the kidneys. So you can see mercury can act on the brain, destroy the brain cells. So each of those has difficult, but those are precursor for tumors, and then it goes to the last stages of cancer. So especially benzene, asbestos, and all this the PCBs here, same thing. So all those are tumors, precursors. They can cause cancer. So how we define pollution sources? Well, we talked about this. Point source is a smokestack or some other concentrated pollution organ, correct? So that's we know the source of the pollution. We know the source. Open point, or that's, the source is known. So the source is known. So you know what you are dealing with. You know what you are expecting if in case an accident. So you know what you will expect in case there is an accident in the source point here. It's well known. So, and in those open sources, you have 3 types of pollutants. You have primary, secondary, and vegetative. Those are the 2 ones here. This is one, and this is not known. So not known. So you have known, which has primary and secondary pollutants, correct? And you have not known, that's number 2. So this is number 1, and this is number 2. So primary pollutants are released in a very harmful form. That's when you have an accident, but you know what they are. So that's the good thing, is you have an open source and you know what those pollutants are. Secondary pollutants become hazardous after they react in the air. And that's, you know, there's, you have sulfur dioxide, for example, here it is. The secondary one, let me just give it another color. So the secondary one here, correct? So here it is. You get sulfur dioxide plus the hazardous comes when they react and they produce sulfuric acid. Okay? Or nitrogen, we'll go nitrogen oxide plus H2O. All this interact with the air. Air has moisture, correct? And you get nitric acid. So those are called what? Acid rain. Those are acid rain. Because when they interact with H2O, then they are washed down as a rain, so you get an acid rain. The interaction, that's the interaction. They are chemically interacting with the moisture, with H2O. So the non-point one, the second type here, the second type, you don't know what's the source of this, which is very, very difficult to know because they don't go through the smokestack or the smokestack means a known place, whether it's a tower, whether it's whatever is in the factory. So you know their place, the sources, and you know what they are. So the non-open source or non-point source, you don't know what you are dealing with and from where you are getting those pollution. That's the same thing in air as well, fresh tap water. Okay, so conventional pollutants are abundant and serious. So they are sulfur dioxide, remember we said lead, sulfur dioxide, carbon monoxide, nitrogen oxides, ozone, all those conventional ones, correct? Maybe I'll just put them here just so you can remember them here. SO2, sulfur dioxide, and you have, those are nitrogen oxides. Okay, you have then ozone, O3, you have carbon monoxide, you have carbon dioxide, all those, you have lead, okay, and can be even out mercury. So all those compound or chemical compounds are really causing this pollution inside the air. And then when they go down on the ground, they are causing pollution to the fresh tap water reservoirs and to the soil too. The soil becomes acidic and it's very hard to cultivate. You have to treat the soil before you are putting any seeds. So all those here for them here, no color. All this, the only color here is this one here. This color here, especially this one here, this is brown gas. All the other ones is dangerous because you don't see, you cannot verify. They look like no color, they like air, nitrogen and oxygen there. So you don't know, but you cannot, CO2 can suffocate, can cause death. You cannot breathe, so can suffocate the person. The NO2 gas, the brown gas here, nitrogen dioxide, can cause, that's what's happened when I was in Colorado, they cause an infant up to 5-year-old kids lung cancer. And therefore you'll see the Mile High city, Denver city, as a city, they have a lot of, you go in the early morning, like 4 or 5 o'clock in the morning before sunset or sunrise, you can see all over the skies are brown clouds. That's just NO2 coming from the
Can I ask you a question?
Yes.
Is that why people that don't smoke usually get lung cancer if they're around people that smoke on a constant basis?
Yes. The second smoker, there is no second smoker. If you are near any smoker, you are the first, the same. You get the same effect. And if you expose yourself to people are smoking, you'll end up having the same problem with your lungs. And that's the reason is the combustion there is you get a lot of soot, like your chimney. Those are heavy smokers. They end up their lungs. They make autopsy for their body at they're dead. They can see their lungs looks very dark black lungs. That's the reason the soot, like in your chimney. See the chimney how it looks? You clean it 100 trillion times. It will become what? It will become black because the trees you have, they have aromatics. They cannot be oxidized. They cannot be combusted. So whenever you have partial combustion and you get soot, that charcoal is not really burned, and that's precipitate on the chimney. The same thing if somebody smokes too much. Besides the nicotine, the nitrogen, that's can cause free radical, can cause cancer. You have this problem with the soot, and that's the reason somebody will ask you, why is the lungs here of the heavy smokers looks very dark black? Well, that's like the chimney you have. So they are inhaling and exhaling all this soot inside their lungs and accumulate it through the ears. And then if this person dies and you make autopsy, you'll be surprised the lung is so dark black like your chimney at home. That's because of the combustion of whatever aromatic inside the tobacco. It's not combusted. It's not reacting 100%.
But now people are vaping.
What's that?
People are doing more vaping than smoking cigarettes now, so that's even worse, right?
This anything you inhale, anything chemicals you introduce into your body, you can always expect that's not good for your health. Okay. Yeah, that's always the case because all these plants, they have a lot of aromatics, and those aromatics are really precursor for tumors and cancers, and they cannot be combusted. They cannot interact or with the oxygen with the air, and they cannot be burned. You burn them, part of them will burn, part of them will not burn. They stay like you see in your chimney, the same thing. So, but anyway, so those are the conventional one. We know them. We know their effect, especially the acid rains. They can really spoil the soil, the humans, the animals, anything they can do damage. And you can see, you have seen statues, old historical statues, even in Europe you can see it. The nose is disfigured, no nose. They were built with the ceramic, whatever, a very good way of, clay or something. But this acid rain is so acidic per time. It's act on those statues there. And you'll see some statues are really disfigured per time. Takes time, but you can see the effect of the acid rain there. So from where? It's nothing comes to the nose of a big, huge statue. So that has to come from the air, correct? And that's the sulfur dioxide here. Those are two main sources. Both of those here, main sources of acid rain. Those are main sources of acid rain. Acid rain. So those are in the air there, and that's what's happened. They destroy all the good buildings, good statues you have, and they do a lot of damage for the soil. Anytime you have a leak of acid rain from the rain into the soil, this soil will be per time. You cannot cultivate any crops inside. You have to treat it first, neutralize those acids by adding, for example, baking soda. Just add baking soda a little bit on it, so you have to treat this soil. So it is beyond repair, unless you intervene chemically and then neutralize this acid. So those are the two parts, major ones, the nitrogen oxides and sulfur dioxides. Those they can cause acid rain by making acids, nitric acid and sulfuric acid. Conventional, furthermore, we said carbon monoxide. Remember, I put them there? I put them a couple minutes ago, if you recall. Carbon monoxide is one of them too. Carbon monoxide is one of them too. The problem with carbon monoxide is this is your hemoglobin of the blood, our human blood or insect blood or animal blood. So it has six, 1, 2, 3, 4, 5, 6. The blood is connected itself to organic, some stuff here, the organic. You don't have to know this, but this is organic. It's called ligands. And that's where the exchange of CO2 out, and they let oxygen in. That's in, this is out. And this is those ligands here, this organic cyclic compounds. And now when it comes carbon monoxide poisoning, will come and say to this ligand, well, I'm more stable, I'm more stronger than you. For adherence to this iron, we'll take this one out, and then you get what? Here is now carbon monoxide. 6 of them. 6. All of the person is blocked. There's no exchange of oxygen in and out. CO2 cannot even come out, and the oxygen cannot come in. So it causes suffocation. So carbon monoxide causes blood blockage. So the oxygen will not be carried into the system, into the blood system, and it cannot be carried outside the blood system. So the person dies from suffocation. There is no way to breathe, correct? Ozone, well, ozone is a pollutant as well because it's a precursor of free radicals. Free radicals are precursor for tumors. So exposure for ozone for a long time can cause cancer, correct? So that's another conventional pollutants we know. And the other one is the conventional, let me see. Yeah, the other ones is not discussed, but we discussed them before, mercury and lead beside those. So we have mercury and lead, we have ozone, we have carbon monoxide, we have SO2, the sulfur dioxide, nitrogen oxides. All those are conventional ones. And those conventional pollutants, they interact with the air itself. And they will, and then you get serious damage. Now, interacting of ozone produce smog, correct? And which are really, the smog is really volatile organic compounds. Those can cause cancer. Those volatile organic compounds can cause cancer. Okay, and those are contribute to the formation of ozone and other photochemical oxidants. A wide variety of these organic carbon-based volatile compounds, evaporated, dry, that are coming from the manufacturers of some plastics, some of them plastics, some of them polymers. So those are coming from there. And then if you have a refinery, crude oil refinery, cracking, they call it cracking of oil, crude oil will be cracked, means chopped into small pieces. Those will generate a lot of this VOCs, volatile organic compound. Conventional pollutants are abundant and serious. Now, this again, we talked about lead, correct? We talked about mercury. We talked now particulate materials or chemicals, including dust, ash, soot, lint, smoke, pollen, spores, and so on. All those are inside the air and cause damage. And the damage, it depends. It depends. Not that some of them serious damage can cause cancers. Some of them just immediate cancer or tumors. And some of them takes long time to see the effect of them. Correct? Some of those conventional pollutants, you have to have time to see their effect on the environment and on humans as well. Hazardous air pollutants can cause cancer and nerve damage, as I said. They can cause a lot of mercury can cause a lot of brain damage. Correct. Lead can cause kidney and liver malfunction. So if somebody exposed to lead, that person will be losing the kidneys, both kidneys and the liver. And if you lose those are the manufacturing organs inside our body. Almost all hormones are manufactured in the liver, and some small tiny percentage of those hormones are manufactured by kidneys. So you have those two type of organs are really manufacturing organs, and if they are failing, there will be no life. Our life will be, you cannot live without those two organs. So, and those are affected mostly by heavy metals, mercury and lead to some extent. Mercury for the brain, but mercury, lead, and all the heavy metals can cause this damage. The hazardous air pollutants, HAPS, chemical can cause cancer. We talked about this. Nerve damage, disrupt hormone function, and fatal development. These persistent substances remain in ecosystem for a long period of time and accumulate in animals and human tissues. So you cannot see some of those conventional pollutants. You cannot see the effect immediately on them. So it takes time. But some of them you can see the effect within weeks, within 1 month or 2 months. If the area is exposed to those pollutants, you can see the effect immediately. So some of them very dangerous, can cause a lot of damage very fast. But some of them, it takes time to see their effect. It takes time, months, years, to see their effect. The TRI stands for Toxic Release Inventory. That helps this established, passed by the Congress in 1986 to help inform the communities, the states and the communities, cities, about the toxic substance produced and handled in their area. And that's related to the open sources. The open sources, you know those factories, you know those chemical manufacturing companies, you know them, what they are producing. So you can use their database and then give it to the cities and to the communities. They know what they are dealing with. In case if there is an accident or something, they know what they are dealing with. So the inventory collects self-reported statistics from 23,000 factories or more maybe now. I think this statistic may be old, maybe more than 23,000 factories, refineries, hard rock mines, power plants, chemical manufacturers, to report all the chemicals they are releasing releasing into the air. I mean, they are allowed just a small, tiny amount. They are not allowed that much. They will be fined and maybe closed if they are doing a lot of damage to the environment by venting a lot of those pollutants. So there are about 667 toxic chemicals. Those toxic chemicals, they have their own management. We call it in chemistry and physics chemical database. So chemical database or chemical data sheets, those are very MSDS is very important because that will give you all the details about the chemicals you are dealing with and what you are expecting in case of emergency. Mercury is a key of neurotoxin. We talked that mercury can cause nerve damage, correct? A small amount, minute doses can cause nerve damage and other impairments, especially in young children and development. They did not tell us about mercury. Mercury can cause, again, those heavy metals are not only mercury can damage the brain, but can damage the kidneys and the livers. So whenever we have metals, they are highly toxic because they are attacking the kidneys and the livers. So besides attacking those two important organs in our body and the animal bodies, mercury can attack the nerve system as well. 70% of airborne mercury is released by coal-burning power plants. You'll see nowadays a lot of countries, they are shutting down those power plants based on coal burning. They have other means to run their power plants rather than just coal burning. Air pollution and climate. Physical processes in atmosphere transport, concentrate, and disperse air pollutants. And that's we know that if you have a large area, an open large area, it has to be open, so the wind can carry those pollutants from not city to city, from continent to continent, believe it or not. So it can those pollutants can be carried from continent to another continent, depending on the speed of the wind, depending on the precipitation, depending on all those conditions with the weather can affect the spread out of those air pollutants throughout the globe, not only from one city to one city. That's easy. That's not a big problem. The big problem, they can transfer from one continent to another continent. And you can see anytime, like China, they have a lot of times in the year that you cannot see nothing. They have a lot of air pollution there and dust and all this stuff, and this transferred to the west side of United States, to Australia, to New Zealand, and this transferring from one continent to another continent or to other continents. So depending on the speed of the rate of the wind and precipitation, all the other conditions. Global warming, in which pollutants are altering the Earth's energy budget, is the best known case of interaction between anthropogenic pollutants and the atmosphere. So, air pollutants travel to the globe. Hi there.
Oh, can we take pictures? Can we take pictures? Who's that? We need a picture. We need a picture.
Come here. I'm recording my lecture. I want your picture to come in near the camera. Come on in. Take a picture of yours here. Is this mine? I want. Yes. Yes. I will come in YouTube though. It will be in YouTube. Yeah. See your picture in YouTube.
Bye.
Thank you. Thank you for coming. Thank you for coming. He can watch he can watch the lecture, correct? He can see his face. I will get a lot of likes in this, correct? I'll get a lot of likes this time. Well, I don't care about likes, but I will get a lot of likes. That's funny, but that's really true. Anyway, that's a good time. So we did not have him in that close contact. I mean, we see him far away every time, but it's very close contact. That's good. So remember, when I retire, I'll go back to this lecture. Anyway, air pollutants travel the globe. That's what I said. So it's air pollution. It's not from one city to one city. That's easy to be done by the wind, and small tiny conditions can move one air pollution from one city to one city. But there is some extreme conditions that can really move this air pollutants from one continent to other continent. That's what I said. That's what it says here. The same thing. So, and these are just examples of what's happening. Dust, fine aerosols, whatever this in aerosols there, you might have acid rain there. You might have maybe mercury vapors there. Whatever inside can be carried great distance by the wind. Pollution from the industrial belt here, just an examples between the Great Lakes and the Ohio River Valley regularly contaminates the Canadian maritime provinces. So you can see it goes from here to Canada. That's from one land to another land, correct? But now you can see that's even what's happening in China as a third example here. Dust storm from China, China's Gobi and Takla Makan deserts routinely close schools, factories, and airports in Korea, Japan, and even Australia is not mentioned, but Australia as well, and Seattle in the U.S. So it really goes from one continent to the other continent. Australia is not mentioned, but Australia part of it too. It's not far away from China, but Australia is a continent as well. So dust blowing from the Sahara, this North African Sahara, is contributing to this type of contaminant, correct? And it goes from the Sahara, North Africa to Florida. Can you believe that? So it goes from one continent to the other continent. And the dust is not only clean dust. You get a lot of junky stuff inside this. As I said, can be mercury, can be lead, can be acid rain, you name it. Can be carbon monoxide. All the stuff can be there. So dust can carry pathogens, and is thought to be a source of diseases attacking Caribbean corals. And not only that's very good to know that bacteria and viruses can be transferred by wind globally from one continent to the other. Not only the air pollutants, but if you have viruses and they are in very small, tiny nano particles, they are in small nano size of particles, they can be shifted by the wind from one continent to the other continent. Carbon dioxide and halogens are the key greenhouse gases. What we said about greenhouse gases, what they do actually, what they do, they contain heat, and that's what the greenhouse effect. They really they don't let the heat go. They're absorbing heat and keeping the heat within their molecules, and therefore you can get this global warming, correct? That's the key of carbon dioxide and some halogens. So the concentration of carbon dioxide in the atmosphere have been increasing due to human activities. Mostly it's coming from the electrical power plants, and mostly will come from automobiles and all manufacturing factories. So the climate is changing because of this carbon dioxide, and the global warming is a fact now, although some people, they don't believe it, but as a scientist, we do believe it. That's those gases, they have the ability to absorb heat and contain the heat within their molecules for a long time. So they cause those carbon dioxide and the halogens. They can cause the greenhouse effect or global warming effect, because they keep their heat is within their molecules. Those greenhouse gases, methane, natural gas, nitrous nitrogen oxide, different one, and the hydrofluorocarbon and perfluorocarbons and sulfur hexafluoride, the sulfur hexafluoride. All those are greenhouse gases, which really they have the ability to retain the heat for a longer time, causing the global warming. These gases are far more potent greenhouse gases per molecule than CO2, and since the recent Supreme Court ruling, the EPA is charged with regulating emissions of all these gases. And one of the ruling is to get out these hydrofluorocarbons as much as we can out of the air. Those here highlighted one, those are causing a lot of, they go and they cause the ozone hole. You remember of the ozone hole, we'll come back to it. Those are interacting chemically with the ozone and depleting the ozone. So they're interacting the ozone, transferring ozone into oxygen in the air, but then the oxygen is depleted from that area. So, and if we don't have ozone, can we live on this earth? Why we cannot live in Mars or any other planet?
Because we need oxygen.
What's that? We can't breathing. That's well. We can breathe, but we can bring some oxygen tanks and breathe. Correct. But there's a major issue here. All the planets around us, they don't have protecting layer. Where the Earth is the only planet of all the Milky Way galaxy that has a protecting layer called ozone. So all the UV radiation coming from the sun, or all the electromagnetic radiation coming from the sun, they will split us in matter of short time. A lot of tumors. Everybody will be running like zombies or tumors all over the whole. And even tumors in the plants too. Tumor can get cancer as well. So we'll get cancer is breaking the cell in small pieces, correct? So those radiation can do a lot of damage, but the ozone is there to protect the Earth from those radiation coming to the Earth. All the other planets, they don't have this type of layer for protection. So in order to get this regulation coming, we have to reduce the amount of the hydrofluorocarbons, not to release it out in the air because they are really depleting the ozone. So without ozone, we cannot live. The whole radiation, electromagnetic radiation will come, X-ray, gamma ray, all UV radiation, microwave radiation, all this radiation coming from the sun will come and affect our life, and our cells really will be broken in small, tiny mini cells, which is the brain cannot control them, cannot put any order to them to do any function. So the whole body will be functionless. You can't function without the brain is giving the orders to do. As now I speak to you, the brain is telling my tongue to talk, correct? So if you have a tumor there, so the brain cannot losing this function, and you cannot talk. Are you following me here? Mm-hmm. And that's the ozone is very crucial for the life on this earth. All other planets, they don't have this. So we can try living in Mars, but we can have oxygen, but who will protect us from the UV radiation coming in the Mars? I mean, without any guard, without any protection, you cannot live in Mars because of this electromagnetic radiation, gamma, X-ray, UV, infrared, all those type of radiation coming from the sun direct on that Mars planet. So nobody can live. Nobody can live. So nobody can live. I mean, because of just the tumors coming in the body, breaking the cells in small pieces. These gases are far more potent. They are really deadly greenhouse gases per molecule than CO2. Since there's just the regulation that they have to be regulated, and they are regulated. They are not used. They are not used that much now. In the old days, all the perfumes are used. They were using this chlorinated carbons or hydrocarbons. They are using it to increase the pressure so that the perfume liquid can get out as aerosol to our body. But now they are using some other stuff different from the hydrofluorocarbons, which can cause. Here we talked about the hole on the ozone, just an example. The damage is still not that large, but at least if we have enough of those per time, they can really deplete the whole ozone, and there will be no life on this earth. There will be no life on this earth. Correct? So those those chlorofluorocarbons or hydrofluorocarbons, they can really deplete the whole ozone layer. Excessive exposure of UV could cause cancer, reduce agricultural production, and disrupt ecosystem. Now, as I said, don't expect us to get cancer in humans only. You can get it in insects, you can get it in bacteria, you can get it in viruses, you can get it in plants. What is really cancer is coming from the tumor, the free radical chemical reaction with the free radicals. So you are chopping the cell, the healthy cell, into many hundreds of small tiny cells, which then the plant cannot have control in the plant. And the brain cannot even have control in it. So the person or the plants or in the soil, anything can lose this chopping the cell in small pieces. So that will affect the control of those pieces, small tiny pieces inside the body in humans and in the plants, and all the stuff here you can see, those can cause a lot of damage. So CVS control has shown remarkable success, and in 1987, the international meeting in Montreal, Canada, produced the Montreal Protocol, which cover major international agreements on phasing out of this CFC by 2000. I think they did it before that. As you can see, by 1996, they decided to eliminate all the CFC, the chlorofluorinated carbon or hydrocarbons. They are out from any aerosol. Anytime you use a liquid, you don't need to use this to increase the pressure and get the aerosol in the air. So CFC are now being removed from the atmosphere more rapidly than they are being added. So they are there, but they are really in a small, tiny amount of concentration, not like before. So, and in this way, then the ozone hole can really replace itself, can really recycle itself. But when it's under attack from this CFC, then it will be depleted very fast. But now, because of the amount of those free radical producing compound, which is CFS, as chlorinated, fluorinated carbon or hydrocarbons, less than will be released in the air. So we have a better chance for ozone to recover. So maybe in years to come, they will see ozone hole will be just recovered. There's no more of this hole. This is just an example. We talked about statues. Remember, can you see the nose? You cannot see the nose. And this statue is very high, very, very tall. So how come it's just the pollution is attacking? So it has to be coming from the air, not from the ground, correct? So you can see those acid rains and all the other pollution inside the air causing a lot of damage of very attractive statues, and that's all over. When I was in Germany, the same problem. So the acid rain dissolved limestone and marbles, destroying features and structures of historic buildings. In Europe, they have the same problem. But now with the control of acid rain, we have this one under control much better than the old days. Inversion and heat islands affect urban areas. The temperature inversion is a situation in which stable cold air rests near the ground with warm layers above. This situation reverses normal conditions. Now, this is the same thing similar to the tornadoes. The tornadoes is different between hot air and cold air. They come and merge because the difference in temperature, they make turbulence, correct? That turbulence is called tornado. And it's the same thing here. The temperature inversion is cold air at the bottom of the ground and warmer air and above it. That's will reverse the normal conditions, correct? And that can cause a tornado, turbulent inside between the air, hot air, cold air, due to difference in temperatures can cause turbulence, can cause tornado. That's what really tornado is all about, correct? Mm-hmm. Smog and haze reduce visibility. Pollution affect rural areas as well, cities. Grand Canyon, that's an example. Long time you can see 300 kilometer, far away. Nowadays you barely can see, the visibility is 20 kilometers, about 12.5 miles. So you can see the visibility is decreasing because of the air pollution. Huge regions are affected by pollution. A gigantic haze blob, as much as 3,000 kilometers, about 2,000 miles across covers much of the eastern part of the United States in the summer, cutting visibility as much as 80%. Air pollution control. The best solution is dilution. Dilution means, as we say, dilution you add in chemistry, you add solvent and make it less concentrated. And in the problems, you chop the problem in small pieces. You don't entangle, you don't fight the whole big problem as a whole. You just cut it in small pieces, and you can have more control in it. So we can do the same thing here for air pollution control. So we can cut the problem in small pieces, and piece by piece we can get this pollution under control. Tall smokestacks were built to send emissions far from the source, where they became difficult to detect or trace in their source. With increasing global industrialization, though dilution is no longer an effective strategy, we have needed to find different strategies for pollution control. Well, it says sometimes cutting the problem in small pieces, you have to have a lot of players playing with you, because you are not alone here by yourself. The other people in the other continents, they have to play with you, so you can entangle this problem in small pieces. But if nobody is working with you, so you're stuck with the problem. So therefore, sometimes piece by piece, fighting this air pollution sometimes might not work. So you have to do the whole problem by itself by adding more players to the team. So more countries, more continents has to participate in this. So the best strategy is reducing production. Well, the manufacturing, the best strategy is reducing pollution, but pollutants can also be captured from effluent after burning. So particulate removal involves filtering or emission filters trapped in a mesh, or electrostatic precipitators are used. That's in the electrical power point. That's just the case in the electrical power point. Sulfur removal is important because sulfur oxide are among the most damaging of all air pollutants in terms of human health. Nitrogen oxide, that's because both of them, sulfur sulfur dioxide and nitrogen oxide causing acid rains, and that can be combusted. The nitrogen dioxide can be combusted. It can be reduced by the combustion of the using some industrial boilers. Hydrocarbon control mainly involve complete combustion or the control of evaporation. If you don't have complete combustion, you get soot, and if you get soot, you get the problem into air pollution. Soot can cause a lot of cancer, especially in infant and small kids. Clean air legislation, controversial but extremely successful. The Clean Air Act 1963 and the Clean Water Act came out, I think, in the 70s, came around 73, came after it. But the Clean Air Act came earlier than that, came in the 60s. So you can see that the air was very obvious to see the effect of this pollution. Came the Air Act before the Fresh Tabor Clean Act. So in 1970, an extensive set of amendments essentially rewrote the Clean Air Act. In 1990s, amendments included major changes in incentives as well as rules and regulations for those pollutants. In 1990, amendments are also provided incentive and rules to support development of alternative fuels and technologies. And one of those technologies you can see, catalytic converter, was in the 50s, 60s, even 70s, 80s. There was no catalytic converters in all cars in the whole globe. But now it's a must to have catalytic converters, so at least to get rid of those. You don't have this nitrogen, sulfur, and carbon pollutants coming in the air in a very what they call it, in a very dangerous way. So the whole emission test is very important, because then you can see how much carbon coming out of the engine, how much nitrogen coming out of the engine, how much sulfur coming out of the engine, because the catalytic converter is breaking those down into harmless compound. Then, but if you have a leakage inside your engine, then you see some of those will be vented into the air. 80% of the United States now meets the national ambient air quality standards. Most of the pollutants have declined sharply since the introduction of Clean Air Act rules. And many places have really improved. As you can see, low-income countries can control air pollution too. Delhi, India, was considered the largest polluted area, but now it's improving. In 1990, in the 90s, catalytic converters, as I mentioned here, were required for automobiles, and unleaded gasoline and low-sulfur diesel fuel were introduced in 2000. Private automobiles were required to meet European standards. In 2002, more than 80,000 buses, auto rickshaws and taxis were required to switch from liquid fuel to compressed natural gas. And if you look at MARTA, all MARTA buses are running at what? Gasoline? No. They are running using compressed natural gas. Correct? Sometimes they can use compressed air, but they are using compressed natural gas. So this will conclude chapter 9 and 10